Dart school presents sine, cosine and tangent. At the very basic level, trigonometry is the study of the relationships between the sides and the angles of right-angled triangles. Recall that similar triangles have the same angles in them and the ratios of the corresponding sides are fixed. And that's irrespective of the sizes of the triangles. Let's say we have a right triangle or a right angled triangle. This angle obviously is the 90 degrees or the right angle. Let me name this triangle as ABC and also let me name this angle as theta. It's a Greek letter. If we have another similar triangle, which means the sizes, the lengths of the three different sides can be different from what we have on triangle ABC, but then the angles are exactly the same. So this angle is also theta. Let me name this triangle as PQR. And because the two angles on the smaller triangle are each equal to the two angles on the larger triangle, and given the fact that the sum of all the angles in any triangle is equal to 180 degrees, it goes without saying that the angle out here, angle A, has to be equal to angle P. We say the two triangles are similar and the corresponding sides bear the same ratio. The ratio of corresponding sides are fixed, which means AC on this triangle over AB. AB is the hypotenuse. Let me write a H for the hypotenuse, and this is the hypotenuse, the side opposite the right angle on the larger triangle. Also, I'm going to go ahead and call this side the adjacent to angle theta, so I'm going to write that as A for adjacent, and this side AC is the side that's opposite to the angle theta. I'm going to write that as O for opposite. Same thing with this triangle. This is the opposite side to the angle theta and this is the adjacent side to the angle theta. So we have on the two triangles AC, the opposite over the hypotenuse is equal to PR over PQ. I'm actually going to change this to H1 and H2 to indicate the two hypotenuses, the lengths are different. And same with the adjacents. So let me write ADJ1 and ADJ2 for the two adjacents, and OPP1 and OPP2 for the opposites. So coming back to this, we have AC over AB, which is equal to PR over PQ, which is equal to the opposite over the hypotenuse on each of the triangles, and this is defined as the function sine of that angle theta. If you change theta, this ratio is going to change, the opposite of the hypotenuse. In the same way, we have a cosine function that's called cosine theta, and that is equal to the adjacent over the hypotenuse. For the smaller triangle, it's going to be this length over this length. For the larger triangle, it's going to be this length over this length, and essentially this over this is equal to this over this as long as you keep the same theta on both triangles. And there's one more function, it's called the tangent or the tan theta, and that is actually equal to the opposite over the adjacent defined for each triangle. So for the smaller triangle, it's this length over this length. For the larger triangle, it's this length over this length, and essentially it's the same as long as this angle is the same in both triangles. I would like you to note that the hypotenuse in a right triangle is always fixed. It's always the side that's opposite to the 90 degrees or the right angle. But then the choice of the opposite and the adjacent sides really depends on your choice of theta. So if this is theta, the angle opposite to theta becomes the opposite side. If you were to name this angle over here as theta, then this would become the opposite and this would become the adjacent, and the same goes with this triangle. So to sum up, the hypotenuse is absolute, it's fixed, but the opposite and the adjacent depends on your choice of theta.